Hello, my name is Gabriel Aka, and this is my lab report for Lab 2, Lines of Charge. Introduction. The purpose of the experiment was to use clear tape and simulate the transfer of electrons between surfaces and calculate an estimate of the charge and number of electrons transferred on two pieces of tape using a VPython program. Some fundamentals behind the experiment was that the electric force between point charges is given by Coulomb's law, which is Fe equals to K times the first charge times the second charge over R squared. Newton's second law, F equals ma, and Newton's third law, the force object A exerts on object B is equal in magnitude and opposite in direction to the force exerted on object A from object B. And the main results from the experiment, or the lab, was that the magnitude of the electric force on the top tape was found to be 1.766 times 10 to the negative third newtons. And the charge on each tape was found to be 2.391 times 10 to the negative 8 coulombs. Assumptions: air resistance is negligible during the duration of the lab. Each U tape had the same net charge, and each tape had the same amount of charge evenly distributed along its length. The two models for this lab was Model A from Lab 1, where the two tapes were put up in this experimental setup, and it is also modeled in the Glowscript code, which is coming up. And Model B was the free body diagram acting upon the top tape, tape B. And this is modeled as a point charge, has a dot, but in the experiment it was modeled as a full rod or tape, and it includes the gravitational and electric force. Data and calculations: the mass of the tape was 1.8 times 10 to the negative 4 kilograms. The distance between the tapes was 0.025 meters. The gravitational force was calculated on the top tape by using mg, which is found to be 1.766 times 10 to the negative third newtons. And the electric force was found because the top tape is in equilibrium, it's equal to the gravitational force. And the charge on each tape was found using the equation on the left, which is the equation for the electric force on a rod, which is Q times the electric field of a rod. And yeah, it's that big equation. Here is my Glowscript model. On the left, you can see the physical constants, the mass, and the estimated net charge, as well as the distance between the tapes. In split between the first image and the second image is the electric field function I used to calculate electric field, which was calculated in Lab 0. And then also is the line charge function, which created the line of charges shown in the Glowscript model, which was not created by me, but was in the start code. And in this image is the top tape and bottom tape, which initialized the top tape and the bottom tape in the Glowscript model. And then there's also the electric field scale used in calculating the electric field arrows shown in the model. And this image is the calculation of each electric field from the bottom tape on the top tape and their respective arrows, in addition to the electric force arrow at the bottom and the gravitational force arrow at the bottom. This was the final model. The blue balls, or the blue tape, is the bottom tape, while the red tape with the red balls were the top tape, and the green arrows resemble each electric field. The electric field that the bottom tape exerts on the top tape. The white arrow represents the electric force acting on the top tape, and the yellow arrow represents the gravitational force acting on the top tape. That magnitude and the magnitudes of both forces are seen below. Discussion. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. The point charge model was calculated in the previous experiment with both tapes being modeled as point charges. And the charge on each tape from that lab was found to be 1.11 times 10 to the negative 8 coulombs. The line charge model, which was calculated during this lab and is shown in the calculations over here, was found to be 2.3914 times 10 to the negative 8 coulombs. And why do these estimates differ? Which value is more likely to be closer to the real value and why? These estimates differ because one considers the length of the entire tape in addition to the distance from the tape to the observation point, while the other only considers the single point at the center of the tape that contains the total charge, and it uses that point charge, or that center of the tape, as its distance to the observation point. Finally, the line charge value is closer to the real value because it models the interaction of electrostatics more realistically, as most things are not considered point charges. They have charges that are evenly distributed along its entire surface. And yeah, that is my experiment. Thank you for watching.